What's up everybody, this is Cakez and welcome back to another tutorial in which we animate our character. First, make sure that you have the correct updated sprites. Again, you can get it in the repository in the description. For this tutorial we need the 12th frame animation of Celeste running, and then we will use this middle frame right here when we jump. To start, I want you to switch into the assets.header file, and then below the sprite Celeste we're going to add in two more sprites. The Celeste run and the Celeste jump animation is going to be added here, and then further down below in the sprite struct, I want you to add in an int frame count. This is exactly what you think it is. It is the amount of frames in a sprite sheet. By default it is 1, of course. And then further down below in the getSprite method right here, we add in the sprite.frameCount and set that to 1. We don't actually have to do this since we're setting this to 1 already, but I'm just putting it here for safety precaution. And then obviously below the Celeste sprite, we add in the sprites for running and jumping. The running animation starts at 128, which is right here, this top left corner. It has a size of 17 by 20, which I already said before, and a frame count of 12. The jump animation is just one frame. It starts at 229 and has a size of 17 by 20. And that is this sprite right here. If you don't like it, you can use any other sprite that you want on these, or you can draw one yourself, of course. That is everything in the assets. Make sure that you save that and then switch over to the game.h file. Scroll down to above the player and then add in an enum player animation state. For now we will be handling idle, running and jumping animations. And then further down in the player I want you to add in these fields. We need an integer for rendering options. We'll get to that in a second. We need an animation timer to keep track of in which frame we are based on some sort of loop, let's say 1 second. And then that animation timer will index into the correct frame index. We need an animation state that tells us, okay, are we running, idling or jumping? And then we also need to hold information about which sprites we actually want to render in each of the corresponding animation states. And so for now, ignoring the rendering option, I want you to go into the game.cpp file to where we actually update the player. It is in the simulate function, and then there we have the update player section. The first thing I want you to do is set the animation state to idle every time we update. This is going to be the default animation state if we have no input or nothing happens, we are just standing there. And then further down below, when we move left and move right, this is when we actually want to change it. So for example, if we move left, we have to differentiate between two cases. Are we grounded or are we not grounded? If we are grounded, then we want to do our normal run animation. If we are not grounded for now, we're just going to jump. And so when we move left and right in the air, we will just display this animation frame right here. Obviously, we want to do the same thing when we are moving right. If we are grounded, then we run. If we are not grounded, then we jump. There's also a different way we can do this. For example, you can extract this jump animation right here. And then you go to the top where we jump. Below that, we paste this in. And then we can check if we are not grounded. Then we can set ourselves to jumping. That would always display our jump animation when we are not grounded. And then the only thing we have to check in these here, are we grounded or not? If you want to do that, you can do it this way. Both of them works. But this alone is not enough. Just changing the animation state is not enough. We also need to increase the timer. So whenever we are moving left or right, I want to increase the timer by delta time, the run animation timer. So that means when we are standing still, we are not going to change it. Now that we have set up the change of data, I want you to change the initialization of data, which means we go to the initialization of the game over here where we initialize everything. And I want you to add in a section for the player. Oh, and by the way, if this is annoying for you that this sound plays all the time, you could just comment this out. Okay, so the player, we get the player reference and then we set the animation sprites. Idle is on idle, jumping is on jumping, running is on running. Very simple, but we have to set this up and fill this in once. Now that we have initialized the player, we also need to change how we draw. So further down below the simulation, right where we draw the player, instead of just drawing the sprite, we need to get the sprite and then call some sort of animate function that takes in however many frames we have, a duration for the loop, and then a timer. And then it gives us an animation index back between 0 and the animation count. And then we draw the sprite of the player based on the animation state and that sprite that is in the state on the player position. And then we also have to fill in or give the renderer the data about what animation index we have. And this rendering options we'll leave out for now, but basically what will happen is the player will flip the X coordinate left or right depending on where he's looking. Otherwise we would always look to the left. So yeah, we have to delete this draw sprite and then we need to implement this animate function. And we do that in the rendering interface. So we switch over to this into the section renderer utility. quality. Okay, let me scroll up real quick. The animate function, as I told you before, takes in a time pointer because we're going to change it. Then it takes in a frame count and a duration. Again, if you don't like using pointers, you can also use a reference here. It's fine. But we're definitely changing it because the moment the time is greater than the duration, we're going to remove the duration until we are below the duration. That makes sure that we are always between 0 and the actual frame count. Then we calculate the animation index. Basically, we take the value of the time, divide that by the duration, and then multiply that by the frame count. Very simple. I think you can understand this. Then we also have to make sure that we clamp the animation index by the frame count, because that can actually happen with this method. So we need to make sure that we're never actually getting to the frame count, but at least one below. And then we return the animation index at the very bottom. Now that we have the animate function and we save, when we go back to the game CPP, the only thing that is complaining about is the actual last part here, the data that we supply to the function. And in the rendering interface, we have to add in one more structure that holds in what I call draw data. This draw data for now is going to hold the animation index and rendering options. Later on, it will also hold color and maybe some other data that we need. But for now, these two are fine. And we need to supply this draw data to the draw functions. For now, we only need to supply this to the sprite, the draw sprite function here. When supplying the draw data to these functions, we do it in both functions, and then we call the draw sprite at the bottom with draw data. And in the real function, we also supply the rendering options to the transforms, and then we calculate the atlas offset based on the animation index of the draw data using the sprite's size. And so this is how we're going to animate our character. We take the base value on the atlas, and then we offset that by the sprite size, however many slots. Now this can obviously be dangerous, which means if we supply too much, it's going to be invisible. But it should be fine. I've never had any issues. Unless you supply deliberately bad values, nothing should be wrong here. You might have noticed the rendering options on the transform. We need to supply these on the transform as well, which means we have to change our transform by including an int rendering options. And now this is where I want to get into a little discussion surrounding our situation with our shaders. For example, in our vertex shader, we have the same transform struct. And if we want that struct to be the same struct that we supply on the CPU, or that we have on the CPU, we obviously have to change that here as well. But this becomes a problem very soon, because not only do we have to change this part, we also need to change constants. You might have noticed that the rendering options in the transform is an int, and I want to use this rendering options as a bit mask. So for example, the flip rendering option to flip x coordinates of our sprite is the bit 0, and the rendering option to flip y coordinates is the bit 1. That makes it easy to pass in a lot of data while not spending a bunch of data on booleans, right? A bit mask is very cool to use here. But if I want to do that, I have to switch into the vertex shader, and then first I have to define a bit. I don't have to do it, but it's easier to type otherwise. And then I have to define these rendering options at the very top, otherwise they are not known in the shader, and then I don't know what I'm talking about if I go down here where the texture coordinates are defined, and I would like to check whether I want to flip x or flip y, which means that we have to take the left coordinate and swap that with the right, or we take the top coordinate and swap that with the bottom one. And also, by the way, I noticed that these are floats. These should actually be ints, so please change these coordinates to int coordinates or types. So you might notice that this is getting very tedious, and you would be right, because I also forgot, not only do we need the rendering options, we also need the int animation index in here. Now that I have done this here, I also have to go into the rendering interface and supply that here too, int animation index. And so the next tutorial, I want to make a unified shader header that looks something like this. Let me make this a little bit bigger. We basically have a define at the very top that checks whether we are inside the engine or not, or inside the shader. And then you can see this define right here, right? We can define constants, and we can define stuff in the engine so that we could talk about a generic transform, and then we only change this in one place, and it corresponds to all other places as well, or it propagates. For now, we're going to do it like this because it requires a lot of structural code. If you run the game now, you should be able to run the character and then jump with it, but you see that we cannot switch from left to right or from right to left. This is one last thing that we have to do in the game, and that happens when we simulate the game. So basically we want to switch over to the simulate stuff, and then where the player is on top of the jump section, I want you to put in the facing in the right direction part. Basically, if our speed is greater than 0, then we don't want to change the sprite at all. But if our speed is less than 0, we walk to the left, then we would like to flip the x coordinate. And this is why we need the rendering options on the player, because otherwise we won't be able to keep track of where are we facing right now. If we now start the game, we should be able to run to the left and to the right and jump into both directions. And this is everything I wanted to show you in this tutorial. Again, in the next one, we are going to clean up a little bit with the rendering part. And yeah, I hope you enjoyed it. Please leave a like and subscribe for more if you did. Until then, have a good one. Peace!